So today, as we continue on in lesson 7.2, this is what we are going to look for whenever we see that we have a 4-term polynomial. Notice right here I say we're going to try to factor by grouping. Now all of yours today you're going to be able to, but not every 4-term polynomial can be factored by grouping, okay? So I'm just, kind of putting that out there for you right now, that you just need to make sure that you always, that would be your first move. See if you can factor it by grouping. So we'll practice that today. So when we have a 4-term polynomial, we're going to make 2 groups of 2 terms each. Because if we have 2 groups with 2 terms in each, that should cover all 4 terms. Then, after we've made those groups, we're going to GCF each group. So we're going to find the greatest common factor of each group. They're kind of like separate of each other for a little bit. We're separating them out and saying, you have your own GCF, I have my own GCF. So we GCF each of those 2 groups. And then we say each group should have a common factor. In other words, when you do get done GCFing them, each of them should have a factor that looks exactly the same. And that becomes now the GCF of the whole 4-term polynomial. So we're still doing a lot of greatest common factor. It's just going about it with grouping. Okay, so here's an example for us just to study for a second here. 6x to the 4th minus 4x cubed plus 12x minus 8. I did 2 things in the next step. I changed the subtraction to add the opposite. That's always we're going to continue in that. Change subtraction to add the opposite. And then I let the first 2 terms become a group by putting parentheses around them. I let the other 2 terms become a group by putting parentheses around them. Then the next thing I did is I said, okay, what is the greatest common factor of that group? So today our goal might be not to have to show quite as much work. Can you start doing some of that dividing out in your head? And if you can't, then you need to go over like on the side of your paper and say, okay, I have a 6 and a negative 4. What would be the greatest common factor of 6 and negative 4? 2. I have an x to the 4th and I have an x cubed. What would be the greatest common factor of those 2? X cubed. So then I say, okay, well then 2 times x cubed becomes my GCF, which is 2x cubed. So if 2x cubed is the greatest common factor of just those 2 terms, that group only, now I have to take the 6x to the 4th and divide it by that 2x cubed. So what is 6 divided by 2? 3. What is x to the 4th divided by x cubed? If you have 4 x's upstairs and 3 x's downstairs, what do you have? X. So that's where the x comes from. So after we divide 6x to the 4th by 2x cubed, we have 3x. That's our result. And then we do the same thing with the negative 4x cubed. We say, what is negative 4 divided by 2? And that is negative 2. And then we say, what's x cubed divided by x cubed? They cancel each other out. There are no x's left. So we just have our negative 2. So that's just GCFing the first group. Our GCF of that group is this, and the resulting factor is that. Just like what you practiced for today. And then we go to the other group and we say, okay, now it's time to find the GCF of that group. And we have to find the largest common factor they have. Well, both terms don't have x's, so we already know we can't divide an x out. But can we divide something out of 12 that can also be divided out of negative 8? We can divide out 4, right? So 4 gets divided out. After it's divided out, we have 3x. Negative 8 divided by 4 is negative 2. Now, notice something about, so here's our greatest common factor for the second group. And notice something now about these 2 factors, the resulting factors of both of them. What's true? They're exactly the same. They are both 3x plus negative 2. So 3x plus negative 2, because they both have that factor. I need you engaged here. Because they both have that same factor. factor, that becomes the GCF of the whole thing. Now we're back to thinking the whole polynomial that had 4 terms to start with. We're saying that is the GCF of the whole polynomial because both of them have that factor, both of them have it. So now that's the GCF. And then we have to say, okay, after I divide this one, after I divide it by that, what's left? This. So there's my result from dividing. After I divide this whole thing by the 3x plus negative 2, what's left? The 4. So there's the resulting factor. So we GCF first in little groups. Then we come and find the GCF of the whole thing and say, okay, that's one of my factors. After I divide it out of both of those pieces, what do I have? Here's the resulting factor. And then I just cleaned it up.
I don't understand that.
Yeah, it's tricky.
I'm completely lost.
So we'll start practicing it now.
Alright, can you say that last part again?
Okay, this went from here, from this step to here, you mean?
Yeah.
Okay, because they both had this 3x plus negative 2 in common. They both were being, that was one of the factors, right?
Yeah.
Because both of those had that, this becomes the GCF now. We're back to thinking about the whole thing all together. This is a GCF. We're saying they both are, one of the things that's being multiplied is 3x plus negative 2. So we say that's a GCF now. After you divide this first 2x cubed times 3x plus negative 2, after you divide that out of there, you have a 2x left. Or 2x cubed left, I mean. So that's what comes over here. And then after you divide out this one, you have the 4. So GCF, resulting factor, cleaned up. Haley.
Okay, I thought the
Lots of stuff going on in here. Go ahead.
I thought the 2x cubed plus 4 was the GCF.
It's the GCF of the first group. Only of the first group. Remember, we're starting first by just doing little groups. It's kind of like we're separating. It's kind of like we're separating that 4-term polynomial into 2 binomials.
So the 3x plus negative 2 is the GCF of the whole thing.
And then the 3x plus negative 2 is the GCF of the whole thing, all 4 of them together. And then we think of them as, well, wait a minute, they were together in the beginning. So now I'm going to say I found the GCF of the 4 of them together by separating them out for a little bit. And then now I come back and say, okay, well, this is the GCF of the whole thing. What's the result after I divide that out? Okay, let's come down here and practice with this first one. Any subtraction to change? No.
No.
Okay. So we can go right to grouping, can't we? We're going to say this, we're just going to group them in the order that they are.
Is it okay if I just did that right away, like I put parentheses right
Well,
up
you shouldn't, because then when you look at your notes, you're going to think that's how it started, and it didn't start like that. The first step is change subtraction to add the opposite, and then you can stick your parentheses in there. Well, we got to skip the subtraction part. So I would not just insert them in that first line. Show how the polynomial started before you, because this is really our first step, making the groups. Okay, now each group is going to have its own GCF. So I'm going to look at the first group, 6a cubed plus 8a squared. What's the largest number that divides out of 6 and 8?
2a squared.
2. And a cubed and a squared?
A squared.
A squared. So there's our GCF of that group.
And then you just take that 6a and move it down.
No, you
No.
divide it by 2.
Now you're going to do the dividing.
Oh.
Remember the dividing that we did?
Isn't that
Be 3a plus 4.
Okay, so basically what we're going to do now is we're going to take 6a cubed and divide it by 2a squared. 6 divided by 2 is 3. A cubed divided by a squared is a. Plus.
Oh, why does
8 divided by 2 is 4. A squared divided by a squared. Cancel each other out. There are none, right? So we're just going to stop right there and say, if we look at that 3a plus 4, is there anything else that you know of other than 1
No.
that would divide out of both 3a and 4?
No.
So did we get a good GCF?
Yes.
Okay. If we multiplied that back out, would it get us back to the blue, 6a cubed plus 8a
Yes.
squared? So
Plus 2.
if I took 2a squared times 3a, would that be 6a cubed? If I took 2a squared times 4, would that be 8a squared?
Yes.
Okay, then we're ready to say, okay, let's move on. Let's do the next group.
This blows my brain.
What's
It'll
this?
be 3, I know that already.
Okay,
It'll
3
be
is the
8.
largest number, but
3A.
well, wait a minute, do they?
No.
The
Just
12
3.
doesn't
Just
have any
one.
A's. Yeah, the 12 doesn't have any A's, so we can't take any A's out, so we're just gonna say 3 is our GCF,
Times 3A.
Plus 4.
3a plus 4, yeah. And at this point now, we can say, guess what? This can be factored by grouping because they both have the same factor, 3a plus 4.
understand what's going
Haley.
on.
Is that gonna happen every time where it's the same?
It should today while we're practicing this, yes. Okay, so if this doesn't happen today, then you know something went wrong and you need to go back and reevaluate. Because while we're learning how to do this, I'm going to make sure it happens for you every time. I pick problems that it will. Okay?
So where do you get the factor name at?
Okay, now, this is the one they have in common, right?
Yeah.
So that becomes the first factor. It's the GCF of the whole thing. Well, we're going to, remember when you GCF, you have to divide the GCF out of each piece. This is a piece right here, you guys, right here. This is a piece. And this is a piece. And we are dividing 3a plus 4 out of each piece. So if I take 3a plus 4 and I divide it out of this first piece, what's left?
2A
2a squared. Plus,
3.
I say
Oh,
if I
that's
divide it
the
out of that one, I have a 3 left.
And that's the answer?
And that's our answer.
Well, I was looking at
So
this.
basically,
whole-
it's your thing and then the 2.
This right here is called
Ratio.
factored, I want you to put this in your notes, this is called factored form. This is what we were trying to get to.
What?
So that whole 3a plus 4 times 2a, that's the whole factor form.
Yep,
Okay.
that's our
This
answer.
is easier than the stuff
But
we
now-
did before.
Wait just a minute now, we're gonna make sure though, we're gonna make sure that we have the right answer, that's why we have so few problems to do. We're going to check it today. We're not just gonna
No.
stop and say, oh, I'm good, I got an answer. We're gonna check by multiplying it out. Multiply the factors. Make sure it gets you back to the 4-term polynomial you got. So this is our answer right here, you guys. This is our answer. But we're going to do a check problem and make sure we have a good answer. Yes, Haley?
So is this where we can move like the rectangle?
This is where you can use the rectangle, or because it's a binomial times a binomial, what's another method?
FOIL.
We use FOIL on this one. Okay, so go ahead. You use the rectangle method or the
Yes.
FOIL method.
Yep.
Choosy.
Wait, which would we getting for this?
Now, what should happen, whether you use the rectangle method or you use FOIL, what should happen is you should have no like terms. Do you have any terms that are like terms? No. Out of your 4 multiplications. So, because none of these, there are no like terms, now what we're going to do is we're going to take them and we're going to just write them down in the order from largest degree to smallest degree standard form. So this would be the one with the highest exponent is the a cubed, so 6a cubed, plus, the next one would be the 8a squared,
Plus 9A.
the next one would be the 9a, and the next one would be 12. Now we go back up and we look to see, is that the 4-term polynomial we started with? It is? Okay, then we say it checks. We did well.
Well,
Good
that
job.
is just neat.
Okay, what part of this did you
Wait.
get? What part do we need to talk about on this one before we try one more? So not only are you getting it in factored form, but then after you have it in factored form, you're going to do a check problem. You're going to multiply it out and make sure it takes you back to the 4-term polynomial you started with. And you can use the rectangle method, or you can use FOIL if it's a binomial times a binomial, or you can use vertical. So we got different methods of multiplying, but you can't forget how to multiply also. Okay, anybody want to talk about this one? Okay, then let's go to the back side. Change the addition to subtraction. That's our first move. 3x cubed plus negative 12x squared plus x. I don't want to give the x up in the corner first. Yeah, thanks. Cancel.
It does that every day.
It's Monday, that's why it's doing it.
I did it
Plus
Friday.
x plus negative 4. Okay.
Parentheses.
Parentheses can go in also now. Group together. Okay. Now after we have groups, what do? We have to find the GCF of the first group. So what's the GCF of the first group? 3 can be divided out of both 3 and negative 12. And
Squared.
x squared can be divided out of both of them, can it? Because there's 3 x's in the first one, there's 2 x's in the second one. So we should be able to take out an x squared. So we want to make sure that both of them are divisible by 3, and that's the largest number because 3 can't be divided by anything other than 3 and 1. And negative 12 can be divided by 3. And both x cubed and x squared can be divided by x squared. Okay, now what's the result after we do that?
X.
What's
No.
3x? What's 3 divided by 3? 1. And what's x cubed divided by x squared? X. So again, if you need to go, off to the side and you need to say, I gotta see that. I gotta come over here and I gotta do 3x cubed over 3x squared, and you gotta see that so you know how the 3's cancel. There's 2 x's here that will cancel out, and so we'll only have a 1 up here, so it'll be x to the first.
So.
And then plus, what's negative 12 divided by 3?
Or
Negative 4. And then what's x squared divided by x squared? 1. So they cancel out, right? Okay. Plus. What's the GCF of the next group? 1. And we have to write it. Remember how sometimes we actually have to write that GCF of 1. Sometimes we do. So this is one of those times we have to have a GCF. Even if it's just 1, it's okay. So x divided by 1, x. Negative 4 divided by 1, negative 4. Okay, remember we have 2 pieces here. We have this one. This is a piece. This is from our first group. Here's another piece. That's from our second group. Each piece should have something in common. What do they have in common?
The x plus the negative 4x.
The x, well, not negative 4x, but x plus negative 4. Isn't that what they have in common?
Did I say x?
Yeah.
Just kidding. I lied.
So, after we divide x plus negative 4 out of the first piece, what's left?
1.
No.
Out of that?
After we take the...
Oh,
we
3x squared.
Isn't 3x squared what's left?
Yeah.
After we divide x plus negative 4 out of the second piece, what do we have? 1. So, but we're going to clean this up yet, right?
So you're going to do
So
x.
this
subtract
cleaned up would
4,
be x take away 4,
and then
3x squared
plus 1.
plus 1. Here's our factored form. There's our final answer. So when they tell us to factor it by grouping, we just did. This is its factored form name, which is going to be useful when we have to start solving these. Okay, and we're not done until we do what?
Check on.
A check problem. Okay, let's go ahead and do our check problem. So we're going to check. We're going to multiply our, and I'm going to, at this point, I'm going to change add the opposite back again. I want my subtraction to be addition to make my multiplying easier. And can be FOILed again. It's binomial times a binomial. Rectangle.
Or the rectangle.
Vertical. And this time I'll do the rectangle just so we can remember how that works too for those of us who might not be using it because you've forgotten it.
Ooh.
And after what should end up happening is you should really not probably ever end up with today any like terms. And so you want to put them in the order that will get you standard form so that you can go back to the very original form that clean it up and make sure it looks like what we started with. Is that what we started with? 3x cubed minus 12x squared plus x minus 4. It checks. Okay. Any questions? Okay, then you have 6 problems to do, but they are considered done until you also have a check problem for them, okay? Even if the jurors don't tell you to check, I'm telling you you have to. Anybody? Any lingering questions before we send you on your way?